Hello everyone, welcome back to Data Bracket. Today I'm back with a new video where we are going to build a no-code analytics service purely on Streamlit, and we are going to deploy it on Docker. This service is going to use only input values and checkboxes to perform some analytics on our input data and plot some graphs using the data that we pass in. Let's see what we are trying to achieve here. Alright, this is what our end product will look like. So we are trying to build something like this which accepts input values. So basically the motto is to connect to S3 bucket in our AWS account, where we'll have our data files like CSV or whatever files you have. We are going to read those files by just passing the input variables, the file name, the bucket name, and the access and secret keys for the AWS account through IAM policy. And the service will load the data automatically for us. We don't have to write any Boto3 code. If you're wondering how to build that logic, there is a video in my channel already, and I'm going to place the link in the description as well. Please do check that out. So using this input configurations alone, we are going to perform analytics. Like if you want to load the data frame, we can click on this checkbox and the service will automatically load the data frame for us, and it will display the data for us. And we can do some analytics on top of the data, like calling the df.describe method on top of the data frame, which will give us the mean, median, and interquartile ranges of the data frame and other stats. And this is a custom function that I have built, which will give us the stats for the data frame, where how many of the columns have null values and how many of the values are actually null, and what are the data types, what is the first row, last row, and does any of the columns have unique values or not. Those data is like presented in this particular method. I'm going to show how to build the logic for this and how to place them logically in Streamlit, so that everything as we see is aligned here. You guys can build your own services and publish them on Streamlit, or you can publish as your own custom deployment. And we have a input column which will accept the column names that we want to plot from the main data frame. This is going to be a multi-select option, like we can select the columns. We can select as many number of columns as we want, like from all the columns, and we can plot different graphs. For now I only have 4 graphs, so let's try with histogram. So for these both columns, our service will create histograms. We can see the histograms are created. If we want to plot box plots, the service will create the box plots for us. These are the box plots. And if we want pair plot, the service will create the pair plot for us for these 2 columns. This will be auto reloaded and everything is saved in the Streamlit cache, so the load time is very low, as you can notice. We can select more columns as well during the runtime without making any changes, and the plots will auto update. And we can see the plot is updated. The pair plot is uploaded with 3 columns. We can plot different graphs simultaneously. We can plot histogram and pair plot at once. Hist plots will come in, after that the pair plot will be loaded. Yeah, we can see this is actually working, and this is running inside the Docker. Currently my service is running inside the Docker, as we can see here. So I'm going to show how to build this into a Docker image and how we can create a logic to load the files from S3 dynamically. This is already recorded in other session. You guys can check it out. As I said, do check the description for this. And I'm going to walk you through the logic that I've built for the Streamlit that actually aligned our elements in the web page, and how they are actually interconnected and how they are acting together to form an analytics service which don't need any code, and it does all the job behind the scenes. So now for our code walkthrough, we have all our imports. We have Streamlit, pandas, matplot, and seaborn. Pandas is to do analytics, and seaborn and matplot is for plotting. The file uploader is a class which is part of our widget process. So if we can see here, we have widget process class inside our file uploader file. This is the class that is responsible to connect to AWS through the configurations that we pass during the runtime, and read the data for us through the methods. Those are read bucket and list bucket. This is up to you guys if you want to read one file or read multiple files by listing the bucket and looping over the bucket list. This is already recorded. Please do check out the video. I'm not going to spend time on explaining what is happening here. So we are actually importing the widgets process into our Streamlit main file. This process will enable us to call the read file method on top of this class, and post instantiating we can call that. So before that I have set the column, like entire web page configuration of our Streamlit to wide layout, so that the input values and the graphs and everything will be loaded to the page wide. All right, and we have uh, two columns here which I have created just to add the information specific to the channel. Let's ignore this. Yeah, we are instantiating the widget process here, and this process will allow us to call the read file. So before that I have created two methods, describe df and load df and inspect df. These are the three methods that are part of our UI, which we saw here, right? We have three parts, right? File to data frame, which is nothing but this test.csv will be loaded to data frame, which is the load method, load df method. The next one is describe df method, and third one is inspect df method. Those are the three methods that we have. So describe df and load df are doing nothing. They are actually expecting a data frame, and they are writing the data frame to the Streamlit using the st.write method. The describe will call the describe function on top of the data frame additionally to put up the stats on the page, and df will simply load the df and write it to Streamlit page. And this is where the interesting part happens in the inspect data frame method, where I have created custom logic. This I actually found it online, and I have actually modified it to add more columns. It is nothing but a simple method that expects a data frame, and it creates a data frame out of the input values that it actually parses through that data frame. It actually finds how many of the values are unique, the cardinality, and if it have null values, and how many values are actually null, first row, last row, and d type. These are all aggregated and into a data frame, and we are returning that data frame and writing it to Streamlit using st.write method. So these are the three methods responsible for our analytics, and we have plotting methods also that come after a while. So let's get to that in a while. So I have created a simple try except error handling method, where if we don't pass any input values to our process initially, the Streamlit should not throw any error. That's why I'm simply using a try expect. First thing we are doing is setting the figure size for all the plots. This is again optional for you people, but I'm plotting them in a specific size so that they'll be cleanly displayed on the page. So first thing we are doing is we are calling the read file method on top of our instantiated class, and using that data frame we are actually creating a method called read csv and passing the data frame to that read csv method, and using the pandas read csv method to read the data frame and return the data frame after the pandas reads it as a data frame. This st.cache data will actually uses this method, and it will load the data into the cache of Streamlit so that we can reuse that cache instead of reloading the data again and again. This is a very nice method. If you guys can utilize it, you can optimize your Streamlit applications very well. And using this method we are actually calling the read csv method, and we are passing the data frame, which is actually the byte stream that we received from the boto3 method after our instantiation of the class. And we are passing that byte stream converted to a data frame into a df variable, and using this df variable we are going to perform other operations on top of it so that we can present the data on our page, right? So if our data frame is not none, if it is not empty, we'll perform our operations. First we are calling the load method. This is nothing but a checkbox. We have a Streamlit header which have here we can see file to data frame. This is the header, and we have a checkbox called load. This is the checkbox. The variable name of this checkbox is load, and if that checkbox is checked we are calling the load data frame. That's it. Nothing fancy happening inside here. If the checkbox is checked, we are calling the load df method that we created initially and writing the data frame to the web page using Streamlit. The same operations applies to all other three operations that we have, description and the inspect method, as we can see here. So if describe checkbox is checked, we'll call the describe method, and if inspect checkbox is checked, we'll call the inspect method. So this is pretty straightforward. I think we are good so far. Now let's get to the part where we have this multi-column select option. So Streamlit have this method called multi-select on top of its Streamlit class. So this will actually give us option to pass the columns that we want to display in this drop down here so that we can select them. So I'm actually using pandas inbuilt method, which is nothing but data frame.columns.values. This will give us all the column names as values, and I'm creating a list out of that, and I'm accumulating that into a variable called columns, and I'm passing that column names to this multi-select method. That is giving me this clean drop down which have all the column names of our data frame. Using this we can plot our graphs. Right, this is the multi-select, and using this multi-select we are plotting the graphs in the next stage. So we have actually 4 checkboxes for 4 different plots. You guys want more plots, you can add more checkboxes, but for me I am only using 4 columns. Streamlit have this columns method which actually gives us a columnar operation where we can plot our information in those specific columns. So here I have 4 columns. Each column will hold 1 checkbox for us, and I have created one more columns container which will actually have 3 columns. These columns will hold our graphs. So how many ever columns that we select in this multi-select, that columns will be splitted into list of 3 sets, and using that list of each every set we are going to pass those values of that particular set to these 3 columnar plots. Right, you'll get to know the logic as we go along. So these are the 3 columns and these are the 4 checkboxes. So we are using columns method to create those, and I'm actually passing all these columns into a list so that I can loop over them later. So with the first checkbox we are going to create this checkbox with the first column. With first the logic to use the columns is by using width of column 1, we want this to be displayed in that column 1. So we want the checkbox to be presented in that column, first column. So we are having load hist plots as the name of this checkbox, and we are putting it in the column 1. Right, so inside the column 1, if this is checked, if the checkbox is checked, we are giving it as a header, and if the length of our selected columns, whatever we are selecting here, these columns are being added into a selected column method. This multi-select variable returns a list of columns that we select. So I'm actually accumulating all of them in selected columns variable, and inside this selected columns variable I'm passing, if the length of this list is not 0, we will perform our operations. Right, so this is not 0 as we have like 3 columns right now. So what I'm doing is, for the length of these columns I'm using start, which is 0, and the length of the column which gives us 3, and I want the step to be of 3. So I'm actually splitting the list. If we select 10 column names in that multi-select button, we will have a list of lists. In that, every element of the list of list will have 3 elements. Right, let's say we have a list like 1 2 3. Yeah, this is the list. Let's assume this is the list. If we call this for loop and we use that start, end, and the step function, we will get a list of lists like this. Yeah, this is what we will get out of this for loop, and we are actually parsing those column names, and we are actually appending that to the sliced list in the end. If we have only 3, then only 3 of this 1 to 3 will be appended to the sliced columns. If we have 5, then 3 will be in one list of list, and 4 5 will be in another element of this list. So that is how this logic will break the code into parts, so that we can use them and plot them into graphs of 3 each. Right, so with the sliced columns, for every element in that sliced column, so let's say we have 1 2 3 in 1. So first element, this will be x, and inside that x 1 2 3 we'll take the first element of 1 2 3, which is 1. So for the first index, like for the index 0 or index 1, we are going to use the column. These are the columns, right? We'll get 1 2 3. So we will use column 1 of 0, which is the first element, and we will plot our figure. That's it, nothing fancy. We are looping it twice using the sliced columns. First we are having a list, we are breaking it into a list of lists, and we are looping over the end list, which is the list of lists, and we are passing that index values into a column list that we have, and we are actually plotting our graphs into every single column. So this will happen in a loop. So for every 3 values we will have 3 of this. So let's say if I have to select one more, then we will have one more extra line here. 1 2 3, we'll have one more here. Yeah, so here we can see this. If we add more, 2 more will be added into this column list. That's how the logic works, right? This is not done anywhere online, so I have to make it little out of my own. This is a custom logic and this is boilerplate code, so please bear with that. The same logic is used for box plot also. We are just calling the ax.boxplot here instead of histogram. Rest all is same, we'll get the box plots. And we have a line chart, which is nothing but the line chart of the Streamlit method. Streamlit extensively offers a method called line chart. So I'm calling that line chart method, and I'm passing the data frame of the selected columns, which will give us the line chart. We haven't witnessed how line chart works. It is not so useful in this case, but let's see how it looks for these 4 columns. So yeah, this is the line chart. It doesn't give us much information, or doesn't portray what is happening in the data, but I just wanted to put it there, and you guys can add any other charts that you want. Either it is Seaborn or Matplot or PyPlot, it's up to you. And one more is pair plot, where I'm using Seaborn's pair plot method. I'm passing the data frame of the selected columns, and I'm using the Streamlit's pyplot method to plot that figure variable of this pair plot. That is all there is to this entire service, which in the end gives us a no code service. We can add any number of other operations on top of this service, and we can make it extensively available. I'm going to deploy this online, and I'm going to pass the link to this service in the description, and you guys will have the link to the code of this entire service in my GitHub page. The link to that will also be added in the description. Let's see how the Docker is built. So we are using Python image 3.10. It's up to you which version you want, but try to use Python 3.9 or above to keep up with the new updates, and you guys will not break, your application will not break with new changes of Streamlit or Python. And we are declaring the work directory as app/stores under user directory, and I'm copying all the important files that I want, which are fileloader.py, which is our custom logic to connect to S3 and load the files. Streamlit main.py is our Streamlit file, and requirements.txt is the requirements file, which is needed to install the packages inside the Docker container, and the data-packet png file, which is the image file that I have added here. This again is the column function, and this 3 parts are in one column and this image is in another column. So after copying everything into the source directory, I'm calling the pip upgrade method, and I'm calling the pip install requirements.txt with no cache, and I'm calling the streamlit run streamlit main.py. This will expose port 8501. Let me show how that works actually. Let me build this Docker image in front of you guys so that you guys will have an idea how to build it. So we can simply call docker build the current directory where our Dockerfile is located, and we can tag it as data bracket streamlit demo service. This will build our Docker image by first calling the Python image from the Docker hub, and it will create our work directory, and then it will copy the files into the work directory, and it will upgrade the pip, which is happening right now, and it is installing all the packages into our Docker image. So this would take a few seconds. I'm using Python 3.10 extensively to reduce the load time and the size of our Docker image. If you guys want out of the box even custom function, then you can use Linux Docker image also. So I don't think it would take more than a minute. It would be done any moment now. It's right now 30 seconds, and I think it has already downloaded all the, okay, still continuing. Okay, now I think it is bundling the whale. While this is happening, guys, if you guys need any custom operations to be added to this service, please to leave a comment so that I can add those functions and I can publish them on the GitHub, and I might create a separate video for that. Or if you guys have any requirement for specific Docker tutorials or anything related to data engineering or machine learning operations, please to leave a comment. I am happy to create a demo and share it with you people. Yeah, the wheel build is done and it is actually logging the image. Okay, the image is built, so let's do docker image ls, and we have a docker image which is created 10 seconds ago. So let's run this docker image. Docker run. Let's expose our 8081 port. Right now my application, the old application, is running on 8081, so I'm opening 8081 port, and Streamlit offers 8501 port, which is currently running inside the Docker. So traffic from 8501 will be directed to 8081, and we'll call the image, like name of our Docker image, Streamlit demo service. So did I give a wrong name? Oh, my bad, there is a typo in the bracket. Oh, silly. Bracket, this should work. What is happening? Okay, let's copy the name directly instead of me manually typing it. I think there is some typo. Let's run this. This should work now. Yeah, it is running, and if we go to 8501 port, I think we should see our 8081, sorry, 8081, and our application should come up. Yeah, this is our application. This doesn't have any keys. Let me pass the keys on a live, and we can see how this actually works. So access key goes here, secret key goes here, the bucket name goes here, and our file name test.csv. We hit enter, we should have all other options. That lets us do the job without any code. Yeah, we have all our options loaded in. We can see inspect, this will give us the stats. Load, this will load the data frame. We can plot, we need columns. Since we don't have any columns, it says no variables found. Let's use these two columns, and it will give us the pair plot in the end. Alright, yeah guys, that's all I have for this demo. I think this was useful for your learning journey, and I think you guys learned something about Docker, Streamlit, or Python in the process. Please feel free to leave a comment if you have any requirements, or do subscribe to the channel and not miss on any content that is going to come up in the future, and like the video if you really liked it. Thanks for sticking till the end. Bye.